This is section 2.11 in your textbook on absolute value equations. But let's review first, what does absolute value mean? When you see those vertical bars around a number, the absolute value of -3 or the absolute value of +3, absolute value is the distance from 0. And it's always a positive value. If you were talking about distance from your house to work or your house to school, your distance would always be a positive number. I drove 5 miles, I drove 10 miles. You would never say I drove -5 miles or I drove -10 miles. You'd always use distance in a positive way. So it's always a positive number. So if we're thinking about a number line with 0 being in the middle, and then -3 would be 3 units to the left, the distance to 0 is just 3. It's 3 units away from 0. So the absolute value of -3 is just 3. Same thing with +3. The absolute value of +3 is still 3 units away from 0. So whether it's a negative inside the absolute value bars or a positive inside the absolute value bars, the end result is the same. So if the absolute value of x is 3, then x could be +3 or x could be -3. You always have two answers. Same idea here. If the absolute value of y, or any letter, equals 7, then y equals +7 or y equals -7. This means that absolute value equations almost always have two answers. There's one exception which we'll see later, but most of the time absolute value equations have two answers. And I call this, you always split absolute value equations into the positive and the negative option, and then solve for x on each. So I call this splitting absolute value equations. So let's look at one together. I have the absolute value of 5w plus 3 equals 7. And there's two options here, and I always draw little arrows to split my options. That means that 5w plus 3, the expression inside the absolute value bars, equals +7, or 5w plus 3 equals -7. So it's either +7 or -7. And you can put the -7 first and then the +7. It doesn't really matter which way you write it, but whatever the expression is, the expression stays the same. The result that's outside the absolute value bars, you have a positive or a negative. Then we'll solve each one. This does tend to lead to fraction answers, that just happens. Divide by 5. W equals 4/5. So if I plug in 4/5 for W, the absolute value would be 7. And then I'm going to solve over here. Divide by 5. You're doing the same math, just with different numbers. And if I plug in W equals -2, again, when I take the absolute value of that expression, I will get +7. So you have two answers. They're both valid. You put them both in my math lab as valid answers. If you'd like to pause the video and try example 2 on your own, you're welcome to do so, or you can just follow along with me. Again, we have the absolute value of an expression equals an integer, or it could be fraction or decimal. Usually it's integers just to keep it easy. We're going to split this into two possibilities. 2x minus 3 equals +5, or 2x minus 3 equals -5. I'm going to solve each one. These should be pretty simple to solve. 2x equals 8, divide by 2. X equals 4, there's one answer. 2x equals -2, divide by 2. x equals -1, there's your other answer. So +4 or -1, both of them are valid answers. Let's go ahead and look at example 3. I'm going to again split this into two options. X over 2 minus 1 equals 11, or x over 2 minus 1 equals -11. You can use the fraction technique we discussed in the solving video, or because these are both integers, it's a little bit easier if you just add 1 to both sides. And then I think of this as x being divided by 2. So what you can do is multiply both sides by 2. This is if you have a fraction on one side and an integer on the other. It's a little bit easier to use this technique. But you can use the other technique, you'll still get to the same answer. Same idea on the other one, I would add 1 to both sides. That's going to give you x over 2 equals -10. And again, you can cross multiply, you can make common denominators, lots of things you can do. I'm just going to multiply both sides by 2. You get x equals -20. So as long as you get those two answers, your technique is up to you. If you want to pause the video and try example 4, or you can follow along with me. We're going to split x over 5 plus 1 equals +15, or x over 5 plus 1 equals -15. Again, whatever technique you want to use here. I'm going to move the 1, and then I'm going to multiply by 5, undoing that division. 14 times 5 is 70. Same idea here, I'm going to move that 1, and then I'm going to multiply by 5. And -16 times 5 is -80. Use your calculator, don't just guess that or try to work it out, just multiply it in your calculator. So you're going to get two answers, not always integers. Sometimes they're both positive, sometimes they're both negative. A lot of times one is positive and one is negative, but they can be any numbers. Whatever numbers makes this expression make a valid equation. So it could be any numbers. Traditionally you have a positive and a negative, but that's not always the case. The next piece is the same idea, just kind of an added step here. You do not split, you don't split into the two options until you isolate the absolute value expression. So one thing students might do with a different color or highlighter is kind of emphasize where the absolute value expression is. Just the part in the absolute value bars. We want to isolate that part, we want to get that part completely by itself before we split it into the two options. So on example 5, you have the absolute value of 2x. That part's in absolute value bars. Then the plus 5 is not equals 11. So before I split this, I'm going to move that 5. So the absolute value of 2x. And when you write absolute value bars, make them very distinct, not parentheses, not brackets, not the number 1. Make it very clear so you can see it. Equals 6. Once you have the absolute value expression isolated, and then you split. So 2x equals +6, or 2x equals -6. Solve, this should be nice and simple. X equals 3. Solve here. X equals -3. So again, two answers, not always related to each other. Just two different values for x that make the equation true. If you want to try example 6, you can pause the video or you can follow along with me. Again, I'm going to move that number that's on the outside. 14 minus 8 would be 6. I'm going to make sure my absolute value bars look like absolute value. Then I'm going to split 3x equals +6 or 3x equals -6 and solve for x. These are fairly easy, just don't lose track of where you're at. I ran myself out of room. You should get x equals 2 and x equals negative 2. Both valid answers. On example 7, it looks trickier, but it's just the 2 on the outside. We need to move it to the other side. Absolute value of 5n equals 15. Once you have that absolute value expression isolated, then you split. 5n equals 15, or 5n equals negative 15. N equals positive 3, or n equals negative 3. So most of the time you'll get 2 answers. Again, not always related to each other, just 2 answers that make the equation true. On example 8, there's a couple things we have to look at. We need to move that 5. We have 2 times the absolute value of x plus 1 equals 8. A lot of students are tempted to distribute the 2, but these are not parentheses. Your brain thinks they are because they look similar, but they're not parentheses. So we're not going to distribute that 2. We can't change what's in the absolute value bar. So those are kind of locked up. We don't change it. Instead, we're going to divide by 2. So we're going to get the absolute value of x plus 1 equals 4. And so we have x plus 1 equals positive 4. Or, whoops. X plus 1 equals negative 4. And again, I ran myself out of room. Your answer should be x equals 3 or x equals negative 5 if you subtract 1 from each one of those. Positive 3 or negative 5. So those examples were just to show to isolate the absolute value bar before you split it into the 2 options. Turn over to page 3. There's a few more to look at. The absolute value of an expression, not the answer you get, but the absolute value of the expression, can never be negative. And this doesn't happen very often. It's just something to keep in mind. Every now and again, a negative will show up. Your answers can be negative, but the absolute value of an expression cannot be negative. So if I have the absolute value of this expression, and I'm saying it equals negative 7, when I take the absolute value of anything, any number I plug in for x, no matter what, when I take the absolute value, it's not going to be negative. That is not possible. Remember, absolute value is a distance. It's a measure of distance. And we would never say we traveled negative 7 miles. Even if we traveled south or drove in reverse, we wouldn't be driving negative miles. Distance is always positive. So it's not possible to take the absolute value of something and get a negative result. So this would have no solution. Again, if you're getting no solution over and over again, you're doing something wrong. Every now and then, very rarely, you'll get no solution. It does not happen very often. Let's look at example 10. Only the 2x is in absolute value bars. So I'm going to move that 25 by subtracting it. And I get the absolute value of 2x equals 11 minus 25, which is negative 14. And that should throw up a flag. The absolute value equaling a negative is where you have a problem. So as soon as you notice that, you've isolated the absolute value and you're getting a negative on the other side, you stop and there is no solution. So there might be one homework problem, maybe 2, where this happens. It should not be every problem. Example 11, we have the absolute value of an expression equals a positive number. So that one's totally fine. Let's go ahead and solve it. We have 2x minus 5 over 3 equals 7, or 2x minus 5 over 3 equals negative 7. Again, several ways to take care of this. What I like to do is I think of this as dividing by 3. The opposite of division is multiplication. So to get rid of that, I multiply both sides by 3. Other students will put the 7 over 1 and cross multiply. It does the same thing. These 3's will cancel. And I get 2x minus 5 equals 21. I'll add 5 to both sides. 2x equals 26. Divide by 2 and x equals 13. Again, if you use a different technique, you should still get 13. And same idea here, I'm going to multiply both sides by 3. So this is like dividing by 3. So to do the opposite of that, I'm going to multiply both sides by 3. A lot of times students want to distribute this 3, but really that 3 is just canceling with the denominator. Nothing changes on the numerator. You're just undoing an operation. And again, I'll solve. 2x equals negative 16. Divide by 2. And x equals negative 8. So you should get 2 answers for x. And it's okay for the variable to be negative. It's the expression, the absolute value of the expression, that cannot be negative. All right, and last but not least, example 12. We have the absolute value of 5x minus 2 equals 0. Anytime your absolute value expression, when you've isolated your absolute value, if it equals 0, you're only going to have one answer. So there's only one answer when your absolute value expression equals 0. So because there's no such thing as negative 0, that doesn't make sense. So we only have 5x minus 2 equals 0. 0 is just 0. There is no positive or negative. And we'll just solve that one equation. So x equals 2 over 5. And there's only one answer. That is the only time you're only going to get one answer. Again, it does not happen very often. Most of the time you should get 2 answers. Very rarely you'll get no solution or just one solution.